Okay, now we go on to the third problem in the exam. Third problem here is a motor in the diagram pulling up a crate, and they want to know the acceleration of the crate and neglect friction. They give you the crate weighs 50 pounds, the tension in the cable is given also 80 pounds, and it gives a hint that that tension is acting twice, because that tension everywhere is basically twice, two T's pulling up, so that's a nice hint. The total tension or total force upwards is going to be 2T. And they want to know here the acceleration. So let's do it. So we'll call this the motor and pulley problem. So here, what's very critical in doing the exam is to do the force diagram. So here, I'm going to go right to the force diagram. And the force diagram, here on the exam, you could see that you're going down here with an mg. You're going to have a normal force like this, and then you're going to have, going upward here, these two T's working together. So when I go to the force diagram, 2T, N, and I like to do these things on that little slant. That's my preference. So that's the angle theta in there. Like we saw before, if you drop down like this angle is complementary to that angle. So if you then had this line slanted, this would be theta once again. And you can think of that if this collapses down, this closes down. That's a quick way to check that you have the right angle. So the given is T is 80 pounds. Sorry here about not using metric. Many years ago here. Today I'd be using metric. And then here we have the angles given as 30 degrees. All right, so the equations that go with this, the important one is the one along the slant, which is the 2T. Always good to indicate what you're considering plus. So 2T minus mg sine of theta. See that? When you have that mg going down like that, you can think of that as consisting of the two components. This one here, the mg cosine theta, which will balance the normal force, and this one here down the incline is the mg sine of theta. So you need not draw that diagram. You can just go ahead and write this down in doing the exam. And that's going to equal the mass times acceleration. Now you can be putting the numbers in early if you want. I like to do this. It's easy for me to check and probably get more partial credit if I make a mistake at some point with the numbers. All right, so we just divide by the m. And what I would like to do here is just my preference. Probably put the numbers in if I was in a rush to get the exam done, but I'm just going to go ahead and do this now. Mg sine of theta. I think this might save me time because I know the mg, to put the mg down, it was given also. So the mg, which is the weight, is 50 pounds. So we know the mg is 50. We know the T is 80. So it's just easy for me now. I get the benefit of going faster now. So I have here 160 pounds minus 50 pounds times the sine of 30 over 50 pounds. And this is going to be, times G. So A is, now the sine of 30 is easy, that's a half. You can use a calculator, of course, and you work all this out. You get 2.7 G, and then it's easy for me at this point to put in the 32 feet per second squared. If I were doing this now, I'd probably include another significant figure in there, an intermediate step. And this comes out to be 86 feet per second squared. So it's basically here like almost 3G. So that's cranking away. That's pulling up there. Interesting.